Now, try not to look ahead at anything that's here, but we have a 100-centimeter wire that we're going to cut into two pieces. And we're going to arrange, we're going to bend one piece into a square, we're going to bend another piece into a triangle. Now, I asked people to sketch this situation, and we got a variety of sketches. One common sketch that I saw looked like this. Okay. And we draw a great big rectangle. I don't have room to draw our square. It's supposed to be a square. Draw a great big square here and a great big triangle here. Well, that gives the idea of a square. If this was a little longer, I don't have room to draw the whole square. And this certainly is a good picture of an equilateral triangle, so I saw some pretty good pictures. But why is this not what's being asked by the question? You want to stop and think about that. And what's wrong with drawing the picture like this? Okay? Now, hopefully you've done that and you recognize what's wrong, because if you bend this piece into a square, the square is not going to be that big. It's going to be much smaller because you're going to have to bend it into 4 equal sides. Okay, and if you bend this up into a triangle, well, you're going to have to take it like here and bend it here and here and bend it up into a triangle. You're going to get a much smaller triangle than the one we picture here. So this is not the way it's going to look. I'm going to put an X through that just to make sure we understand that's not the way it looks. Okay, the way it's going to look, well, let's try to draw it to scale. Now, people did pretty well drawing it to scale. And at least one person divided this piece up into 4 parts. Now, I didn't specify which piece would go into the rectangle, which would go into the triangle, but that's the way somebody chose to do it. So we're going to divide this into 4 parts, and each part is going to have a length equal to the side, because now if we draw a square whose length is equal to one of these quartered sections of this piece of wire, the total of all those sides is going to equal the length of that piece, and that's how big the square is going to be. And then if we bend this piece into a triangle, well, we've got to divide that into 3 pieces, and each piece gives us the length of the side. So it's going to look like this. So that's a better picture, much better picture. This one actually represents what's going on, as opposed to this one, which had the right idea but didn't get the details correctly. Okay, well, I say that now, if the side of the square is x, I'm saying here that that tells us that the side of a triangle has to be 100 minus 4x quantity divided by 3. How do you get from here to here? Yeah, let's just forget about this and let's see what we can reason out if we know the length of the side of a square. Well, people still have some trouble with this. They say, well, and the question I ask is, how long is this piece going to be if the side of a square has length x? I got x to the 4th. I got x plus 4. How long is this piece? Okay, so the length of this piece x to the 4th, x plus 4. Neither of those is really right. Although you know it has something to do with x and with 4, you're not quite grasping all the details, okay? And whatever you're thinking about it, you know, this is just one example of what somebody could think. And you know, so that was in the right direction, but if you think about it, it's not going to work. Now let's just think about what we would get if the side of the square was some simple number like 10, okay? If the square side is 10, then that means this is 10, this is 10, this is 10, and this is 10. So, if that's the case, how long is this? Well, each of these segments has a length equal to the length of one of the sides. That means the piece that we bend to a square has a length of 40. And people said that pretty immediately. Well, okay, if each of these is 10, then that has to be 40. Okay, what I recommend is that you write out the actual calculation sequence that you use to get that. Okay, so if a square has side length 10, we get 40. How did we calculate that? Well, you could calculate it as 10 plus 10 plus 10 plus 10, or as 4 times 10. And I circled the 4 times 10 as the probably most efficient calculation. Okay? Now, if that's the case, then what's the length of the other piece? Well, the pieces have to add up to 100 centimeters. So if this one has a length of 40 centimeters, this one's going to have a length of 60 centimeters. And people saw that right away. Well, what's the calculation we use? Well, it's going to be 100 minus 40 equals 60. And I circle that calculation because that's how we calculate it. So then, what are the sides of the triangle? Well, if this piece has length 60, how long is the side of the triangle? People were able to say, well, it's going to be 60 divided by 3. It's going to be 20. And they just said 20 because the 60 divided by 3 was quite obvious when you're thinking of numbers. Now, if the side length is x, what do? Well, we do the same sequence of calculations. We just do it with x instead of 10. So where we did 4 times 10 here, well, that piece then has a length of 4 times x. Now that'll be the longer piece. I didn't say the longer piece, but I'm following the same sequence of reasoning steps we used here. Okay, so the next thing we calculated was the length of the other piece. And to do that, we subtracted the length of the one piece from the 100 centimeters. So we do that here. Now we have 100 centimeters. We subtract the length of this piece. We have 100 minus 4x. 100 centimeters minus 4x. I'm being a little fuzzy with the units, but in math courses we always are. In physics courses, and I teach physics, we don't want to be fuzzy with the units. But here we're going to be a little fuzzy. Okay, we understand that means 100 centimeters minus 4 times however centimeters there are in a length in a side of a square. Okay? And then what about the triangle? Well, how did we get the sides of the triangle once we knew the length of the piece that we were going to bend into the other piece, the one we're going to bend into the triangle? We divided that 60 that we got here, the result of this calculation, by 3. So we're going to do the same thing. It's 100 minus 4x. That's how long the piece is that we're going to bend into the triangle. And the length of a side has to be that divided by 3, since that whole piece has to give us the 3 sides. We have to divide that piece. We don't cut it, but we kind of divide it into 3 parts. And one part is the width of the triangle. Okay? So now we know that a square of side x implies a triangle of side 100 minus 4x quantity divided by 3.